Hi guys, I come back again, and today we're going to take another some questions about intervals. We took, I think, two examples about the union of two intervals and the intersection of two intervals. Now we're going to take uh, another example. For example, we're going to say that 1, 3 intersection with 2, 5. As I told you, if you remember, I told you the best way is to draw the two intervals. For example, I'm going to draw from 1 to 3. I'm going to let the 3 just open because it doesn't belong to the interval. I'm gonna make the one kind of like a solid square or something, mentioning that it belongs, the one belongs to the interval. The other interval will be from 2, which is solid 2 because the 2 belongs to the interval, till 5. The intersection, now we're going to choose the elements that belongs to both intervals. So as I told you, we're going to draw a small line here and a small line here, and we can see that the result should be from 2, which is this one, to 3. But we don't know yet if we can make it a close or open. So as soon as because of 2 belongs to the first interval and belongs to the next interval, belong to both intervals, so 2 should be belongs to the result because it's a common element. But we can see that the 3 belongs to the second interval, but it doesn't belong to the first one, so we're going to make it open. That means the 3 doesn't belong to the intersection because it's not a common element between the two intervals. The other example that we're going to take, which is the difference, I'm going to remind you about the difference. We have a definition. We say that a difference between two sets like A minus B contains all the elements that belongs to A and the elements. So wherever X belongs to the A minus B, that means X belongs to the first set and it doesn't belong to the next set. Okay, so if I say for example, if I say that Y belongs to A minus B, that means Y belongs to A and Y doesn't belong to B. We need these both conditions. Okay, I think things here should be easier. Why? Because I'm going to deal with intervals. I'm going to say, for example, I'm going to say, let me make it easier, minus 2 and 4 minus 0, let me make it close, 0 and 5. Okay, let me draw from minus 2 this one. Let's say this is minus 2. How can I draw a line in this application? Should be a way to draw like a beautiful line. Minus 2 belongs and 4 belong. No, that doesn't work. Do it again. Yes, because I need a space to demonstrate what I need to say. And we can see here 4. So this interval, close interval from minus 2 to 4, and the other interval from 0, for example, let's say here is minus 1, and let's say there's 0 here. There's a 0 here, okay, just the center. So the other interval will start from 0 to 5, and it's also close. Okay, now we're going to bring our magic line I'm going to say that I need all this except this. So I'm going to take all the first set and I'm going to delete every element belongs to the next set. Okay, it's kind of like cut. So I have from -2 to 4, and I'm going to delete or make it not belong. I'm going to delete every element from 0 to 5. We have nothing to do with these elements, which is not in both, which is not in the first one, because it's gonna break this condition. So I need just to take all the elements from 0 to 4, including 0. So the result will be the remainder, something from -2 to 0. -2 is existed, and all the elements here are existed, but the 0 has been taken, has been cut with this, so with this interval, so the result will be open. Okay, let me show you another example. For example, I'm going to say the union is too easy, so I'm going to say, like, I'm going to choose for example this one. I'm going to say from -5 to +5. I'm going to say -2 and let's say 3. It's not easy for the people who just none about the intervals. So I'm going to draw the first one from -5 to -5, for example. -5. Actually, I'm just drawing things to make it easier. In the future, when you get along with it, you don't need to draw anything. I'm going to draw the other one, which is, I guess, -4 here, -3 here, -2 here, -1, let's say 0 here. So we have the -2 here. This is -2. I'm going to draw this from -2 to 1, 2, 3, 4 to 3. So this is -2 and 3. The difference is the cut. So I'm going to cut this. I'm going to draw a line. I'm going to cut, I'm going to delete all this, just delete it, because I'm going to take this interval, delete it from it, this segment. Sometimes in real analysis, we call the intervals, we call them segments. The open, we call them, yes, the close, I think, the intervals in general, we call them segments. So the result will be this part, which is from -5 to -2. -5 should be closed because it's not touched, and here we deleted all the element next to the -2, but not the -2, so the -2 will be existed. And on the other side, the remainder will be the 3, which is existed because we deleted all the elements next to the 3 from the left. So 3 is not deleted, so it's existed here. And we're going to say 5. But what we can do, we have 2 separate intervals. We're going to put union between them. Okay, that's the way of showing the result of this question. I think I went too far to explain more about intervals, but intervals is very important in finding the domain of functions. So you need to be very familiar with the intervals so you can solve any domain question. Do you think, guys, we need for example, we need another example? For example, I'm going to give you just one more example. For example, let's say that we have -3 to 4 minus just one number, which is the 0. The result will be -3 and 0 open, union 0 and 4 close. So we took the whole line, which contains -3 and 4, and we deleted just one element, which is the 0. We deleted just one element, which is the 0, so the resultant will be from -3 to 0. It's white, it's not really clear, but I already wrote it here. And no, this is mistake. This is mistake. Will be -3, 0 open, and here will be 0 4. This will be the result. Okay, I think that's enough for now, because we're going to get back to the intervals and details when we study the absolute value and the domains of functions. So see you guys in the next lecture. Please don't forget to subscribe and share, leave a comment, tell me what do you feel about the classes, and there's a donation button over there if you want just donate, because I'm going to explain all the calculus, God willing. Thank you guys.